Hello, this is Greg Serby and the date is May 29th, 2017. Today I'm going to be going over a demo of the product Kubernetes Vault made by Boostport. Right now I'm looking at the Quick Start Guide on its GitHub page, and this Quick Start Guide is going to be the one that I'm going to be following along with for the demo. This is the diagram that describes the Kubernetes Vault system, which is similar to the Rancher Secrets Bridge, similar but not the same. There are two pieces to the Kubernetes Vault application. There's the controller, and there's the initialization container agent. The controller uses protocols like Raft and Surf Gossip protocol to create a highly available cluster. And the way it works is you have an application pod, which includes the Kubernetes Vault init container agent in the pod next to your application. So there are 2 app containers and 3 containers if you count this file storage volume in the pod for your application. You need to tag the pod with an annotation, this Vault app role annotation. And when you start your pod, the Kubernetes Vault controller uses the Kubernetes Service API to talk to Kubernetes to watch for events for when a pod starts with this annotation. When a pod does start with that annotation, the Kubernetes Vault controller reaches out to that pod and pushes a secret ID to the pod. The pod itself has been configured with a role ID. When you combine the secret ID with the role ID, you use the Vault backend role ID backend service, and you give it a secret ID role ID, and Vault spits back out a token that has been set up with permissions for that application depending on its role. So the application can only access certain areas of Vault. Once the Kubernetes Vault init container agent receives this Vault token, it's initialized itself, it puts that token into the volume storage here, and from there your application has to retrieve the Vault token from that volume, and it has to use Vault's API to contact Vault and query for any relevant secrets, such as database password, for instance. So let's get into the demo. Here I have a Cygwin command line with Git installed, where I have cloned the Kubernetes Vault repository, and I'm in that directory. I also have the Minikube environment running right now. That's my Kubernetes environment. I also tried to run this on CentOS, but had some trouble, I believe, because the CentOS Kubernetes environment wasn't working correctly by default, but maybe some other OSs are better, like Ubuntu. But this environment I verified works, so this is the environment I'm going to run the demo in. Here I'm going to start up the Vault pod to provide the HashiCorp Vault service. I'm now going to verify that Vault pod was created and write down its name. I'm also going to check just to make sure the network configuration for this pod looks good, and it does. I'm now going to create a port forward from this pod's port 8200 to localhost on my machine. I'm now going to set the environment variable for the Vault command line so that it knows where the Vault server can be accessed. I'm now going to root authenticate into Vault. The vault-root-token at the end here is actually the password. Since this is a demo, I'm just putting the password on the command line. I have authenticated to Vault. I'm now going to start setting up Vault's PKI public key infrastructure certificates. The reason certificates are set up is I believe the Kubernetes Vault controller queries Vault to get a certificate for itself, and then it uses the certificate when talking to the agent, and that's the HTTPS listed here in step 3. I should note that the security of this system, you would want to add one more thing for production, which is to make sure Vault has TLS or HTTPS turned on. In this demo, I don't have that turned on. However, I do believe the Kubernetes Vault controller to Kubernetes Vault init container agent is a secure line with HTTPS so that it passes that secret ID securely across the wire. And so that is what I'm going through right here to set that up. So right now I'm creating a Vault root certificate authority. I am adding some settings to how that root CA issues certificates, some settings for the certificates that come out of it. I am now creating an intermediate CA. And I have a certificate request for that intermediate CA. I'm going to remove previous files from the last time I did this demo, so I'm just clearing those out. So now my certificate signing request has been signed, and this is the signed intermediate certificate. I'm now going to write that signed intermediate certificate back into Vault. And I'm also going to set up some settings for issuing certificates off of that intermediate in Vault. Now we're going to start up the app role backend in Vault, kind of like a module. We're going to specify that secrets issued for the sample app have certain parameters, secret IDs rather. Now we're going to import a Vault policy file which defines read, write, access to various areas of Vault. We're going to assign this policy to a role. And now when we create a token on that role, it will have that Vault policy. In this case, we're creating the initialization token for the Kubernetes Vault controller. I'm going to write down the token ID, or rather just token. Just write down the token. Going to go into the Kubernetes Vault pod configuration, and since this is its initialization secret for it accessing Vault, I'm going to put this in there, and now we can start up the Kubernetes Vault pods. Take a look at what pods have started. This is a cluster, so I'm just going to take a look at the logs of one of these pods, and I can see some raft stuff, some surf stuff, and it looks good. It's running. I'm now going to read the role ID for our example application, sample app. Now we're going to go to our sample app and give it a Vault role ID. Remember, role ID and secret ID come together to give you a token for your app. The role ID comes from the application, and the secret ID comes from the Kubernetes Vault controller at startup. Now we're going to start up our sample app pods. And we can see they're still initializing. So in this demo, what we do is we take a look at the application's logs, and it will tell us if this whole communication that's outlined here in this diagram, if it all worked. So let's go ahead and look at one of these sample app logs. Let me just fix a typo here. And we can see that it did indeed get a Vault token, and this process went through. This application has a Vault token, which it can use to access Vault and access its secrets. The only part that would be improved for production is to provide it a CA bundle for the Vault service so that this can say HTTPS. And I will go ahead just for show and tear down this environment that I've just created here in Kubernetes. And we can see we've completed the demo, and that is Kubernetes Vault. Thank you.